Hello and welcome to our first algebra lesson. Today we are going to learn a lot of mathematical concepts. My name is Alexander Votyakov and I'm a math teacher and computer science teacher from Russia. I'm here to bring you some of our best top mathematical content via YouTube. It's absolutely free and it is only the first video out of many that are going to be united in one playlist for you to learn your algebra in a fun and entertaining way. So today we are going to talk about fractions. It's only the first lesson, so get ready to ingest somewhere around like 100 hours of content from me, and I will become like your favorite teacher over time. So let's get acquainted. My name is Alexander again. This one's name is Rick. So it's Rick. You see, he's like a green and he looks like a cucumber. So let's start. So in total, we are going to cover a lot of topics. Fractions is going to only be like the first one of them, and we will have like linear equations covered, linear graphs covered, like the ones where you draw the x, y, and like y equals some 2x plus 3 or something like that, and short multiplication formulas, as in where a plus b squared equals a squared plus 2ab plus b squared, and so on. How do they work? How it all like. My lessons here on YouTube, like the whole playlist of lessons, is going to be something that you can skip school. You can skip school totally. You can just learn by these YouTube videos. They are going to be enough for you. They're going to cover everything you need to know from mathematics. That's going to be a lot of content, and it's going to be a top-notch content. You're going to love it. You're going to love mathematics. If you have not fell in love, if you haven't fallen in love with mathematics before, you will after my lessons, definitely. So let's start. Like monomials, polynomials, systems of linear equations, square roots, quadratic equations, and many more topics we are going to cover in our free YouTube course. So let's begin. Let's start with fractions. I think I will divide this lesson on fractions into a few different videos, so don't hesitate and click like and subscribe and go on to the next video if this one is too easy for you. You also can use the speeding up like 2x on YouTube. You just take a look at the bottom buttons on YouTube and click 2x, and let's start. So what is a fraction? Fractions as a topic of our lesson. What is a fraction? Fraction as in 1/2 or like 2/3. It is a number that is written in this special way. It's a number where you have like the top number and the bottom number. The top number is called the numerator, and the bottom number is called the denominator. And this fraction means that you have taken one whole pi, let's say it's a pi, and you have divided this pi into 3 parts, meaning that you have 1, 2, 3 parts, and you have taken 2 out of these 3 parts. So 2/3 is this much. It is less than 1 whole pi, but it is more than nothing, all right? And 2/3 is more than 1/3, and for example, 2/3 is more than 1/2. 1/2 is less than 2/3. Because 1/2 is, you take a pi, I have to draw it next to the half so that it will be easier to understand, right? You take the whole pi, you divide it in 2, and you take 1/2, 1 out of 2. So 2 is the number of pieces that you divide your pi into, and then 1 is the number of pieces that you take as the main source of the number. So let's say we want to draw 5/7. How much is that? It's written 5/7. And how much is that? You take the whole pi and you divide it into 7 parts. So they should be equal, but I'm not that good at drawing. So let's say 1, 2, 3, 4, 5, 6, 7. They are not equal at all because this one is small and this one is big. I'm bad at drawing, as I said. Let's try again. That's a 1, that's 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. All right, these ones look pretty much equal. So we'll take 5 out of 7. So that's 1, 2, 3, 4, 5. This is 5/7. Not that hard, right? This is like the basics of the fractions. You understand what fractions is now. We have just given a definition of the fraction. We now know what fraction means. We still don't know how to operate with the fractions. To operate, we have to like try and find out, try and start. Well, my English is not. We have to introduce some basic operations with fractions. Let's say we want to add two fractions together. It is very simple with fractions that have the same denominator. Let's say we want to add 2/7 and, for example, 3/7. How much are we going to get? To understand this, we have to draw it. So we have to get back to the picture with 7. Delete all these pictures from the whiteboard so that they are not diverting your attention. So what we have here is 7 pieces. I have to draw them again. That's 7 pieces. 1, 2, 3, 4, 5, 6, 7, right? And we have to add 2/7 and 3/7. How much are we going to get? 2/7 is 2 pieces out of 7. So that's it. These are 2/7. Let's fill them up with black marker. And then let's use, let's say, green marker to fill up 3/7. This one is 2/7. And this is going to be 3/7. Let's say it's 1, 2, and 3 pieces. That's kind of obvious, right? Altogether, we have 1, 2, 3, 4, 5. 5 pieces out of 7. So we have divided the pie into 7 pieces, and we have taken 5 pieces out of 7. So we are getting 5/7. The rule is the following: if you add two, if you try to add two fractions with the same denominator, let's say 18th, okay, 3/18 plus 5/18. What you're going to get is you have to keep the denominator the same, and then you have to add the nominators of these fractions together. So that's the rule. Let's write it down with the letters. A b plus c b. I don't know how to say it. Like A is the denominator, B is the denominator. So you add together two fractions that have the same denominator, that is B, and have different nominators or the same. I don't care. So to add them up, you have to keep the denominator the same and then add the nominators together. This is the rule that you follow. But as far as I understand, children who are struggling with math, children who do not know the fractions yet, they are too young to understand the concepts in terms of letters. When I use letters instead of numbers, this is called variables, and this concept is very hard to grasp. So I encourage you to not to try to understand fractions through some kind of rules, through variables, through like these kind of things. I have just written it down to, I don't know, to memorize it, to keep it in head, to use it as the last resort rule if you have completely forgotten how fractions work. But in fact, actually, mathematics does not work like that. You don't have to memorize a lot of things about mathematics. You just have to understand a lot of things about mathematics. Understanding is the key. If you understand things, you don't have to memorize it at all. Memory is probably like the least necessary thing in mathematics. You don't really need memory. You need understanding, you need to be clever, you need to be smart, and actually mathematics makes you smart. So let's go on. Let's proceed to the next topic. We know how addition works. Now let's find out how subtraction works. For example, I'm going to subtract 5/7 minus 1/7. How much am I going to get? This is also obvious because you just have to, let's use 6 because it's easier to divide a pie into 6 parts. They're not equal again. Let's use a little bit a different angle, and we're getting six equal parts. So 5 6 is 1 2 3 4 5. That's it, like almost the whole pie except for one piece. And then out of this 1 2 3 4 5 pies, you have to subtract one pie. One piece subtracted, what you have is 4 remaining pieces. They're all 6 pieces, so what you're getting is 5 6 minus 1 6 equals 4 6. So you keep the denominator again, and then you subtract denominators. Let's say 7 20 minus 3 20 equals 4 20. How did I count that so fast without drawing anything? I just subtracted denominators without touching the denominator. So it's 7 minus 3 divided by 20. I said divided by. Actually, this line, it is the division line. Instead of 7/20, you can write something like that, 7/20. This line, it is used on calculator, it is used on computer to explain division. 7 divided by 20, it is actually 7 divided by 20. It is the fraction, 7 divided by 20. How do I know that? Try, for example, let's try 3/4. 3/4, or written otherwise as 3/4. Let's say you have 3 pies, and you have 4 friends who want to eat these 3 pies, and you want to divide 3 pies equally between 4 friends. How much you're going to get? How much each and every one of them is going to get? To divide 3 pies between 4 friends, you have to divide each pie in 4 parts. And I'm going to get this one. You are going to get this one. Our third friend is going to get this one, and our fourth friend getting this one. The next pie is also divided between 4 friends, and the next pie is also divided between 4 friends. How many pieces of pie have I eaten? I have eaten one from here, and one from here. Altogether, I have eaten 3 pieces out of 4. Like 1 piece is 1/4. I have eaten 3 pieces. Each of them is of the size 1/4. So altogether, I have eaten 3/4 pieces of the pie. That's it. So if I'm trying to divide 3 pies between 4 people, I am going to have each of these 4 people eating 3 pieces, 3/4 pieces. That's how it works. So when I'm using fractions and this fraction line between 3 and 4, it actually means the division, 3 divided by 4. You can see it clearly when you're trying to, like 8/4. How much is that? 8/4 is when you're taking 2 whole pies, you divide every pie in 4 parts, and you have to take 8 parts like this, 8 pieces. So take 1, 2, 3, 4. Where do you get the 5th one? You have to get another pie, and there you have the 5th one, and the 6th, and the 7th, and the 8th. 8/4 is 2 whole pies. It is just the same as like 8 divided by 4. 8 divided by 4 is the same as 8/4, so it is 2 pies. You have to understand that division and fraction is like two sides of the same medal. Let's go on to the next idea. We have these fractions, and we have like they are added and they are subtracted in the understandable way. This should have been very easy. You should have understood it like right away. And we're going to move on to the harder topic of like when you multiply the numerator and denominator of the fraction by the same number, you're getting the same fraction. How do you know that? Let's say 1/2. Let's say 2/4, 3/6, and 4/8. What I'm trying to say is that all these 4 fractions, they mean the same number. How do I know that? Let's draw it. 1/2 is you take a pie, you divide it in 2 parts, and you take 1 out of these 2 parts. This is 1/2. What is 2/4? You take a pie, you divide it in 4 parts, and you take 2 of them, so it is also 1/2. You take a pie, you divide it in 6 parts, and you take 3 out of these 6 parts. It is also a half. And then finally, for 8, you take a pie, you divide it in 8 parts. It's just the same as cutting a pizza. Every pizza has like 8 pieces. Not every pizza, but some of them. 1, 2, 3, 4 pieces out of 8. So what we're having is a half of pizza. 4 pieces out of 8 is a half anyway. So these numbers, they all mean the same thing, but they are all denoted differently. They're all written in a different way. So how can we like manage that? How can we understand what does 1/2 actually mean? How do I understand that 1/2 and 1 second, like a half, means the same as 4/8? How do we work around that? The idea is that when you let's switch to another example to understand it better. 1/3 is actually 2/6. To understand that, you have to draw 1/3 and then proceed to divide. I'm not going to like talk without the picture. This is 1/3. Like imagine that you have your friends over and it's your birthday, and your mother has graciously prepared a pie for all of you, but you have invited two kids to come over, and one of them is your friend and the other one is your enemy, but you have invited him over anyway because he thinks you're a friend, but you don't think of him as a friend, you think of him as an enemy. So you want to, like, naturally you want to give him a bad piece of pie. So you do something to the pie, we don't know what, but like it looks scary, and like that's what you want to, that's the piece of pie for your enemy. So you have like done something to the piece of pie, we don't know what, we're not going to talk about that, but then what you're having there is that like instead of 3 guys at your party, somehow 6 people show up. You know that 1 piece out of 3 is weird, right? And then instead of 3 people, 6 people show up. So you have to take out the knife and you have to divide each piece in 2. To get 6 pieces, you have to divide every piece in 2. And then we are getting 2 weird pieces out of 6. It is still the same number of cake. It's the same number of pie. It's still the same volume, but now it is written differently. Before we have written it like 1 out of 3. 1 big piece out of 3 big pieces is the same as 2 small pieces out of 6 smaller pieces. When we have divided every piece in 2, the total number of pieces was multiplied by 2. Instead of 3 pieces, we got 6. And the total number of weird pieces that are in the denominator was also multiplied by 2. So if you look at this one, you are having the 2 multiplied by 3 here and 1 multiplied by 3 here. And here you have 2 multiplied by 4 and 1 multiplied by 4. You have already noticed the similarities, right? 7/18, for example, equals 14/36. This is all multiplication by 2. This means that if you have a party and you have 18 pieces and you have 7 of them like red pieces and all the other 11 pieces are green, for example, then if you divide every piece in 2, you're going to get 36 pieces total, and instead of 7 red pieces, you're going to have 14 red pieces. That's kind of understandable, right? So we can multiply numerator and denominator of every fraction by the same number, and we were going to get another fraction, and it's not going to be another fraction, it's going to be the same fraction. It's going to be equal to the first fraction, but it is written differently in different numbers. That's not something that is too hard to understand, but still you have to keep it in mind when you're working with fractions, that the same fractions might be written in different numbers. How do we work about that? How do we like proceed from here if we know that 4/8, for example, is actually 1 second? This is called the fraction reducing. When you're taking 4/8 and you turn it into 1 second, by dividing both numerator and denominator by 4, you are reducing the fraction. You can take a look at any fraction and you can see right away whether it can be reduced or not. For example, 6/8 definitely can be reduced because these are both numbers that are divisible by 2. You can divide 6 by 2 and you get 3. You can divide 8 by 2 and you're gonna get 4. In Russia, we write this as follows. We just cross out the number and we have 3 written over it, and we cross out this number and we have 4 written below it. So it's 3/4. This is how the reducing works. You can divide numerator and denominator by the same number and you're still going to get the same fraction because, well, previously we have proven that you can multiply numerator and denominator of the same fraction to get another fraction that is, well, literally the same fraction but written differently. So in the same way you can reduce fractions. And this is actually a big topic in mathematics. Reducing the fractions is something that in most schools only goes around like around 3rd or 4th lesson on fractions. We have finished it in 20 minutes. That's nice. What we're having is, like, let's say you want to add 2 fractions together and they are, well, I don't know, like that's 3/15 plus 2/15. How much are you going to get? We have already covered the topic of addition of fractions, so you have to keep the denominator the same, and you have to add the nominators, 3 plus 2, so it's 5/15. Okay, how much are we going to get after we have this 5/15? We're going to get, well, how can we proceed? Is it the answer to the question already, or can it be reduced somehow? Obviously, it can be reduced because both the numbers are divisible by 5. So you can do that. You can divide it, the 5 by 5 and you get 1. You can divide 15 by 5 and you get 3. So it's 1/3, right? Great. So 3/15 plus 2/15 is 1/3. It's just the same number. If you draw it all, you're going to have like a big pie and you're going to have like 15 pieces. Well, that's going to be hard to draw. Like, let's say 3 pieces and then 1, 2, 3, 4. Like 4 cuts to get 5 pieces. 1, 2, 3, 4, 5. It's the so-called +-1 method. I have a video about +-1 on this channel too. And then 1, 2, 3, 4. 4 cuts, 5 pieces. 1, 2, 3, 4. 4 cuts, 5 pieces. In short, if you have 4 cuts, you're getting 5 pieces. Magic, ain't it? So we have 15 pieces, and you take 3 out of these pieces, and you then take 2 of these pieces, and you add them up together, and you get 5. 1, 2, 3, 5 pieces out of 15, but 5 out of 15 is just the same as 3, like 1 out of 3. So it's 5 out of 15 is the same as 1/3. That's great. So we already know how to add fractions, how to subtract fractions, and how to reduce fractions, and how to multiply them by the same number, the numerator and the denominator. One last topic I want to cover in this video before I'm moving on to the next one is how to add and subtract fractions that have different numerator and denominator, like have different denominators mostly. That's the most important point. For example, I want to add 1/2 and 1/3. How much am I going to get? I don't know. I don't know how to add them up. I don't know. These 2 fractions have different denominators. I can't work with different denominators, right? They are like weird. This is a half, and this is a third. And how to add half and a third? We already know how to work with the fractions that have the same denominator. So we have to probably change these fractions to make them the fractions with the same denominator. Let's do this. For example, 1/3 is, how much is the denominator if I want to turn this fraction into a 6th fraction? I multiplied it by 2, so I have to multiply it by 2 again, so I'm getting 2/6. And if I want to turn 1/2 into a 6th, then I have to multiply it by 3, right? So I'm multiplying it by 3 here and getting 3/6. So 1/2 is 3/6, and 1/3 is 2 sixths. So what am I getting is 6, and the denominator is 3 plus 2, it's 5 sixths. So what I've learned right now is how to add two fractions that have different denominator. That's great. That's like really awesome. How did I come up with this denominator? How did I understand that it's going to be 6? Well, it's easy. I can multiply 3 by 2 and get 6, and I can multiply 2 by 3 and get 6. So this is like the common multiple, the number that is divisible by 3 and by 2 both. This number is very easy to obtain. If you have 2 and you have 3, you just multiply them and you get 6. That's not the best option, because, for example, if you have 4 and you have 6 as the denominators, and you multiply them between each other, you're going to get 24. And obviously 24 is divisible by 4, and 24 is divisible by 6. That's a great number, all in all. But actually, you can get even better number. Instead of 24, instead of multiplying, you're getting 12 as the number that is divisible by 6 and divisible by 4, and it is less than 24. It's the so-called least common multiple, but it's a different topic. I'm going to cover it in another video. And right now, just don't get that in your head, and because your head is going to explode out of like too much information and like too active memorization. Like, don't do that. Just don't remember these things. You can multiply two denominators and you're gonna get a good number, and that's all good. Let's move on to understanding how subtraction works. Pretty much the same. You just have to turn these two fractions into fractions with the same denominator. Let's say I want to subtract 3/5 minus, let's say, 2/7. How much am I going to get? These two numbers, they are different, right? 5 does not equal 7. So we have to turn these fractions into fractions with the same denominator. Cucumber, Rick. How do we do this? We understand what their common denominator is. So it's LCM of 5 and 7. And this time it is actually 5 times 7, so it's 35. But, well, in different situations, LCM is different. Well, I don't care. Don't mind it right now. Let's say 3/5 equals some amount in the numerator and some number in the denominator. It's 35. So how did we get it? We have multiplied 5 by 7. So how are we going to get the denominator? We have to multiply 3 by 7 too. 3 times 7 is 21. So the first number is actually 21/35 minus how much? 2/7. 2/7 is also, it can be turned into some other fraction that is going to be equal to the first one, but it will have the necessary denominator. I'm turning it into 35. Why 35? Because it's a magical number, and that is obtained by multiplying 5 and 7. So 7 times 5 equals 35. It means I have to multiply 2 by 5 too, and I'm going to get 10/35. So it's 21/35 minus 10/35. So what I'm getting is subtraction of two fractions with the same denominator. This means that denominator stays the same, but fractions, well, anyway, the denominators are subtracted. 21 minus 10. So we're getting 11/35. And that's it. 11/35 is the answer to the task. And it is not reducible because 35 is divisible by 5 and 7. And 11 is not divisible by 5 and 7. It's divisible only by 1 and by 11. So we can obviously divide both these numbers by 1. They're both divisible by 1, but it's not going to yield us any good results. So what we are getting is the answer. And what we have just learned is that we can easily add and subtract two fractions with different denominators. And this is awesome because actually this is very smart thing to do, right? We turn these fractions into different fractions with the same denominator. and then we perform the subtraction or addition because it is easier with the same denominator. It is actually possible with the same denominator, whereas it's impossible with different denominators. We have to first do some magic over these fractions, like this, like spinning the marker is also magic. Like you do this to understand like how to add them up. You have to turn them into different fractions to add them up. And well, fractions are marvelous because they can be turned into one another and they can be reduced and they can do things, and that's nice. And this is the topic that you have to cover right after you have covered basic addition, multiplication, like subtraction and so on. After you have learned the numbers and you have learned how numbers work, from then you have to proceed to fractions. And through fractions, we're going to proceed to percents, because percent, like 1%, 2%, like 10%, and so on, like the numbers that adults use to, for example, I don't know, count their money and investments, and like bank statements, to read the bank statements, to understand how sales work in the world of shops that have their discounts in like 15% discount. What does it mean? What does it actually mean? Actually, percents are fractions that have the 100 denominator, but we're going to cover it in another lesson. And then we will move on into the beginnings of algebra, like how linear equations work, how linear graphs work, how polynomials work, how all this mathematical stuff works. But to understand all this that I'm going to cover in the future lessons, you have to first understand the basics, the numbers, the relationship between numbers, and this pretty much, well, where you should start fractions. That's it. So thank you for watching, and like move on to the next video. We're going to meet each other in the next video, and I will take like the last minute to, well, thank you again, for example, and also to just to say that I'm glad that you liked the video, and in the description there's going to be like a few links that will lead to some mathematical courses with me. Obviously in the future I'm going to like do the course in English too, because in Russia I am quite a popular teacher. I have a lot of students in my online courses and in my offline like lessons with me too. So I hope that this way, like, I'm going to widen up my audience to an English speaking ones, and I hope that this video was useful, and I hope that more videos are to come and more videos are going to be useful to you. And thanks for watching again, and I'll see you on the other lessons. Bye.